So, hello. Today we will write some more code to finally do some reading input from standard input. What we have here, let me make it a bit bigger. We have some general architecture. Since last time I added some correct rendering procedures so that interfaces are in place. I also added some comments for future me and maybe for future contributors, so they have a better mental model about what's going on in this system. And now our progress is that we can, let's try running it. And yeah, so now we can do this thing where we say that how do I say it? We put everything on the screen and we put it as the maximum. We put everything we can put in a single screen. Yeah. For example, here we have like 54 lines, and our terminal is exactly 54 lines. If I make it bigger, so we have less space on the terminal, we'll put just 37 lines. So we just query the size which this terminal tells us how many, and we say, okay, print just this many lines, not more. Yeah, this is roughly how it works. And now I think we should start maybe reading some inputs and adding it to the screen. Yeah. What I think we should do is wait for key input. Then when the user presses a key, this key goes written to this buffer. This text is in a buffer, and we use this buffer. We then say, okay, so now the buffer has been changed. Now refresh it so that we can see the changes on the screen. So the flow goes like this. We have our screen, our terminal, let's say terminal. Then we press the button, right? Then we say, yeah, we press the button. Then we write it to the buffer, right? And after that, we refresh the terminal so that we can see the changes. All right. So let's start by reading, just waiting for the user input. It should be the easiest one. For now, we will not try to be super smart and just use standard functions for reading from standard input. I think that should be fine. Okay, this is our old new curses implementation. We can safely delete it. And now we need something to just read the input, right? What we can do. We have our buffer or our screen. We have like a general context, this terminal. There should be some function to read it. In C, it is called something like getCH. So I think it is IO, and maybe it is somewhere here. Maybe we can just put standard input into a reader, and this is the way we are going to do our reading. Okay, so I don't see anything here. So let's try. Let's go to reader interface, or yeah. We have here we have in stream, input stream, and output stream. Output stream is used to display things on the terminal, and input stream will be used to read user input. So we already have here what we need. We will just call it then. Okay, so it is UIVT 100 in stream dot reader. These streams are files, and files implement reader interface, and we can see what this interface entails here. So is this normal size? Yeah, make it a bit bigger. Okay, read, and we have a buffer. Read all, maybe less than buffer length. If the number of bytes read is 0, it means end of stream. It's not an error condition. Okay, I think we should need something like that. We will create a buffer for reading, and we will say, well, read, and we will wait for it in our buffer. Maybe there is a smarter function like read just 1 byte, since for now we don't want to mess with UTF-8. Read byte. Okay, that looks like what we want. We will change it later to a different function for reading all the UTF-8 symbols like German, French alphabets, but for now we should be fine with just read byte. Okay, that sounds simple enough. Read byte. Okay, and we say, so here is our byte. CH, we call it CH for a character, or maybe we can use a full name. Don't have to be like in the C world where they use long, short names. Character. Okay, maybe we can just check this functionality. Do we even have some progress here? Character. Okay, so we want to read it and display it. End of stream. Okay, so I believe it doesn't wait for this byte to appear. So can we tell it to wait a bit? I wonder how getCH is implemented, because I'm not sure if it does some extra stuff, like this man getCH. It's cursor stuff, right? Yeah, maybe it does some extra stuff. There is also like a queue of characters pressed. So maybe a queue is fine, we can implement a queue, but what about the actual waiting for the input? I remember in C there is a standard function in the library too, which just waits for the input, and I'm not sure if we need to do some kind of a while loop to say, okay, if you didn't find it now, let's wait maybe 50 or 100 milliseconds and try one more time. Okay, let's find first let's find the name of the function. C read input, standard input. Okay, read, okay, doesn't add to terminate, to read 1 byte at a time. Okay, so apparently there is this version where we say, while read, while we have read something. What's possible ways? How can we read from standard byte by byte using read? Okay, so we have a similar interface. While read, but while that will, I think this will not wait for the user input. And maybe it is correct that here we don't wait for user input. Let's try to do it in a while loop then. So we will have to use some sleep function. I believe it is somewhere in the time. Sleep. Yeah, here it is. Okay, so later we will do it, I think, with a framework, so-called, which is the asynchronous, like this Nginx thing. How's it called? Event queue. We will have Zik has built-in event queue, which works with async, like this kind of words. We will use that, but for now we will do everything by ourselves. Maybe we'll discover that we don't really need this kind of stuff. While true, so we'll have an ability to interrupt, and we will just read byte by byte character, like so. So this after 2 dots, semicolon, or just colon, this is what our loop will do on every iteration, continue after the first one. So during the first one we will not do anything. We will just, here we will try to print something. If character. So what does it return if it didn't read anything? Read byte, error, end of stream. Okay, I think we don't want an error end of stream. Yeah, errors are kind of too heavy, I think. So maybe I think we want just to get the count of how many bytes we have read. Yeah, let's get something like that. Yeah. Okay, so we will need a buffer. Let's create one. Buffer, and it will be, yeah, we can write it like so, I think. Just 4 bytes, and we will initialize it with zeros. 4. Yeah, I believe it works like that. Now we say we want read. And we go like SelfReadError, so we can get an error. And our error, what is it going to return? I'm not sure completely, but okay. We can return an error, and probably we should also initialize it before we try it. Yeah, just call it, not exactly initialize it. And it returns usize or error. And we will have a variable called number of bytes read, right? Number read. Okay. While this is more than 0, I guess. I have a feeling this will also end up but at least we won't have this error end of stream. This at least we will have some improvements, even if it's not like a real improvement. Okay, so we will read something. Maybe even make it just 1 byte, because we want to read just one. And if we have the very first byte read, we want to output it. And if we don't have, we can just wait. Okay. Let's look again at this example. Character by character. Yeah, I think we should say while true. While true. And we will say this, we will also update this variable, and we will only process it if we have something in this buffer which we have read. So, and processing will, for now, will just output it with a new line at the end. Okay. And yeah, we will sleep for some time, maybe 100 milliseconds. We can tweak this later, no big problem. std time.sleep, and we want to sleep. It is in nanoseconds. I wonder how it is implemented for systems which don't have nanosecond sleep. Yeah, for example, Windows here does not support nanosecond sleep, as I understand, so we try to get the closest millisecond value. Okay. And time sleep dot, there are some constants, divisions, ns per ms, std time and ns per ms. Yeah, that looks right. Okay, so we have a buffer, we read some input, then we indefinitely wait, and we try to read something after 100 milliseconds wait, and if we have read something, then we output it to the console. Let's try running it. Okay, expected type U8, found U1. Okay, maybe we should pass it as a slice. Is this going to make the compiler happy? Or also as an address. Expected type found. Yeah, here too. Is this going to work? F J K Q V E R T Y. Control C. Yeah, it doesn't work because we are in the raw mode. So before that I didn't know whether this black magic works or not, and now when I press Control C, we get an input like cgint, and when I press it, the program doesn't exit. It means that this black magic indeed works. Great news, but now I need to exit from this program somehow. So we will just kill it. Yeah. Okay. Well, that looks good. I feel we have some kind of accomplishment here. So let's try one thing I would like to know is whether this Control C actually sends us a signal, or it is like absolutely ignored, and we should we should inspect that we have this control C here, and we should respond to this control C. And for this we also will need a larger buffer, like maybe 4 bytes wasn't a bad idea after all, like so. And we want to inspect a string, and we want to inspect everything in the buffer. So let's have our command ready, just in case we finish our testing. Okay, expected found 1 literal. Okay, maybe we can do it like so. Is this any good? Okay, I think I need to look at how Zig does things. There is this beautiful operator which is not used very often, but when I need it I forget how to use it exactly. Okay, like so. And what about arrays? Okay, so here we get, well, I had something like that. I just had a number in here. Like so. So why is this not happy? If I put it like so, is this happy now? Okay, it's happy. And what was the last problem? Like so. 4. Ah, I get it, because this number should be what how many elements we have in the curly braces, not the overall. I see. Okay, so let's try F G A J K L semicolon. Now Control C. Let's see what it's going to be. So far we don't see anything. Control D, Control F, Control R. Okay, so my guess is that there are some sequences that are sent, and they're just basically not printable. This is why we, by saying this, we don't really see what's inside. So let's try to get some documentation. We can as well just change it here like so, and we will get a number, but at the same time we will need to understand what each of 4 bytes outputs, and we can get some garbage values or values from something in the past. Okay, let's try it nevertheless. I say a lot of things, but maybe we should just try and see how it goes. So we will, after we read something, we will output what we have in the buffer. And for these values, since they are not initialized, or I mean they are initialized, there will be just zeros. Okay, so let's see. F, we have F is 102. Okay, I remember that A is like 95 or 97. Let's press A. 97, beautiful. Okay, so let's press Control C. And we have 3, just 3, a single byte. Let's press Control D. We have 4. Let's press Control F. We have 6. Okay, so if we have in the first value here a 3, yeah? Let's put it as a comment. 3, Control C. And if we Control Shift C, this is going to change. Shift Control C. No, it doesn't do anything. Oh, look, it did 99. Ah, it's because of C, okay. And also Control Shift is something special in Kitty, the terminal, virtual terminal I use. So maybe it is connected to that we don't get anything from here. Control Alt C. Or Control Alt C changes. We get 27 and 3. Okay, I think this is how modifiers work. They just basically send you several bytes at a time. But here is a deal that I'm not sure how reliable is this thing, because some aspects of terminals are very specific to the terminal. This is why we have this variable term, and it tells, so here is a database of what this terminal can do, and I assume it also has some info on how this terminal interprets things, how it sees things. For example, if I press Control C on this Kitty terminal and on another terminal, I might have different results. We might as well test it, as I think, yeah? Why not? Okay, so we need to kill this program. Okay, so in Kitty, Control C is 3. Let's write it down. Let's see what it is going to be in Alacrity. Here, oops, Alacrity. So, Alacrity, okay, font is big enough, I believe. Zig build run src main.zig. Okay, so we have it. Now press F. Okay, press A. Okay, press Control C. 3. Okay. So this terminal also has Control C3, Control D4. Yeah, 4. Okay. So let's try to make sure that it is correct. Let's see what we have, maybe somewhere here. Escape, this is our escape sequence. Maybe just escape codes. Yeah, it is with CSI, control sequence introducer. Maybe it's not the best, not the thing that we need right now. There are some more pages, and how do we even formulate our question? What does terminal Control C in raw mode? Something like that. Listen for character code 3, which gets sent when you press Control C in raw mode. Okay. So this is an answer that we also want to implement, but I don't know how reliable is that, because later on we can have some problems that not all terminals actually sees the same thing that gets sent to our program. Okay, so they all say that control C should be like catched, and it should work fine. And then do some magic with vyinter. Yeah, we have some magic here related to this. Vmean, vtime, and they also use vyinter. Okay, I think we can be safe with this number 3. We got it at least in 2 terminals. Where we have it? Yeah, here. And we also, yeah, I think we can rely on it, at least in some ways. So let's, yeah, let's do that. I like it. So we will have switch on the buff 0, and we will do it like this. If 3, then it is Control C, and we want to break from the loop. Break. And if it is anything else, we want to do some stuff, right? Oops. Now we just want to output what we have in the buffer. Okay, so I have some syntax errors somewhere. Maybe I forgot how to properly write things, or some semicolon is missing. Okay, break. Okay, this is the hardest thing. Maybe we can ask our Z compile, it will tell us exactly. Oh, of course. Just a silly mistake. Okay, so let's try. Switch must handle all possibilities. Well, we handle it, maybe we should handle it like so, else. Yeah, this should do the trick. Okay, we do everything. F, Q, Control C. Oh, beautiful. So we have our input, right? And we can process it. We can opt out of processing it. I think we are good. Let's commit this. Small progress, but we are getting there. Okay, so now we should tell it use standard input, or maybe process standard input, and print to stderr. Okay, so far so good. Let's move further. So the next thing we would like to do is to add this character to the buffer. We have this buffer here, and we want to add it to our content buffer. For now we will append it, so to the very end. And yeah, this is how we will do it. For this thing to do, we will also need a different structure. For now, we just use a simple array. And when we pass our array of string, or a more correct would be to say when we pass a slice of a string, we just duplicate it and we put it here. And later we do some actions with it. So for now we don't want to mess too much with the optimizations, with the data structure for our buffer. Yeah, we just want to make it work. And now we will need a dynamic or growable array, which is also known as vector in Rust and C++, which I think is not a very good name, but still. And we want to have here an array list. This is a Zeek style of naming such things. So first we will do it in the init, and after that we will just change any use of it. Okay, we get the content, we are okay with that. Then we want to write to the content, we are okay with that, but then this is not what we want to do. We also want to make sure it is array list U8. Okay. And now we want to create an array list from a known slice. I believe there is a convenient function for that. Let's just search for slice. Array list aligned. Maybe somewhere from slice, to slice, from owned slice. So we will have to allocate it one more time, I think. The slice must have been allocated with allocator. Deinitialize with dinit or use to owned slice. So this is one option we have. Do we have any other options? From. Okay, from owned slice. Yeah, that is good enough. So this is our owned slice. Duplicated content. Yeah. And now our content is a const. I don't know. Our content. Now it's our content. Yeah, like that. And it says just from okay. It's just from type of array list aligned. We also will want to mess with alignment a bit, because we will read bytes U8 values, but later we can have the U32 values, because it is UTF-8 and it can have from 1 to 4 bytes, and we will probably want U32 alignment. But we can wait with that. For now we just say from owned slice std. Yeah, let's just create our content type std array list byte, so that we can have we can change it later and it will do basically the same thing for us. From owned slice duplicated content, and we want to pass an allocator as well. Yeah, yes, alley here as well, our content. Okay, so here we have it. Now we initialized it, and now we will need to change the use of it. And if I remember correctly, we can just write items. So we can get a slice self items. It is a read-only slice. Let's check that we still have no problems. No member. Okay, I didn't add it to the right position. Here and here, and as well here. Okay, still works same. Okay, let's commit this change. Use array list for storing in the buffer. Okay, that looks good. Now we here we want to add something to the buffer, and we want to say, so now redisplay what we have. And there is a little problem with I'm not sure which exactly place we want to use to read our input. For example, there are several options. We probably shouldn't do it in the code here. We can say, hey, buffer, say something like buffer, and we say like add or append, right? Then we say UI, refresh, and we get things done, but this will probably not scale very well. So we should probably have some ability to use an interface which will do some things for us. I think it could be window, but I'm not totally sure, because for now window is supposed to be some kind of representation of what the user sees on the screen. So it's kind of read-only mode, and we want something to control. We don't have this control entity yet. What we have though, we have this event dispatcher, just general events, and it is going to say who's going to do what. Well, that sounds like a plan, but even if we are going to use this thing, which is a good thing, I guess, we still have this kind of place where we probably still don't want to manage all that in the event dispatcher, so that event dispatcher knows there is a buffer, and event dispatcher knows when we update this thing we need to redraw the whole thing, or when we update this thing we need to redraw just the status line at the bottom. So there are some options that can be done, and while we don't know what to do, we should probably go with the simplest option and make this event dispatcher the head of our department. It will tell others what to do. So for this to work, we will make it know about the buffer we have. We say that it will store a reference to the buffer. Here, by the way, is a fun fact. This UI thing, I don't know whether it should be a reference, because we will have just a single UI thing, and it doesn't really store much. It has a backend. It's a thin wrapper around backend, and if we look for this backend, it also doesn't have a lot of info here. But it still might make sense to store it as a reference. Yeah, that is somewhat interesting for me. It makes sense to store it as a reference from the engineering point of view, but at the same time we don't have to when we write the program right now, and I always wonder how such decisions should be made. Okay, let's For now, let's store it as a reference. Let's try to be smart. Oh no, maybe let's not try to be smart. I'm saying not the right thing. Buffer. Okay, and buffer. And a dot here. Okay. So our event dispatcher knows about UI, it knows about buffer. So here we want it to append to the very end of the buffer. And probably we shouldn't do it directly telling the buffer. We should have a function which does that for us. Buffer, and we will call it insert append. I'm thinking about insert, because append is like the insert in the very last position. At the same time, we will need to know the length of the buffer. Okay, let's have an append then, because I'm not sure which abstraction is going to be the most correct one. Append, and we say we want just a single character. Yeah. And we can fail, and we say self dot, and we say try, because this can entail an allocation, and allocation can always fail. Self dot content dot append character. Self.content.append character. That sounds correct. Now we say self buffer append. We pass our value. Is this correct? So we get event value, we get insert character, and we get a key, and the key has value u32. Okay, it has some complications because our key has value u32, and it really should be an array of 4 bytes, I believe. Yeah, something like so, and probably a const array. I did something wrong again. Maybe we can do const arrays, just 4 bytes. Maybe we're too smart, so just 1 byte. Okay. And where do we use key actually? Let's see. Key. Okay, so we're generally good, we don't use it that much. Value. Yeah, I don't like this too much, this value thing, and that we have some redundant structure here. But we will simplify it later if we need to. For now, I feel a bit more secure with all this large structure. Kind of feels enterprisey, like we're building something. And we also want the UI to refresh. Self UI refresh. Yeah, beautiful. And it does what it does. Yeah, we just expose it here. Refresh. And we say that it is same as backend. We use inline just because we don't do extra logic. We can as well inline this function. Compiler should be actually smart about inlining, so people say that oh, you don't have to do it, it will be just done by the compiler. But at the same time, I think it makes sense to control it where you definitely know that it's going to be needed. Alright, we exposed refresh, and now the last thing to do is to insert a character, right? We need to dispatch an event with our insert character event. Here we have some boilerplate for key press, like a general event that we press a key, and later I would like to add that if we have if we are in the insert mode, we insert a key. If we are in the normal mode, we do some commands like move cursor up, down, left, right, this kind of stuff. Okay, we have event dispatcher. We have it here, event dispatcher. Now we need to create it, and we need it to create it with the buffer and a UI, just like the window, which is also a bit funny that we have two structures which know about buffer and UI. It is also a good idea to think about is whether how is it going to scale, because we can have several windows for just a single buffer. A buffer will be a representation of the text stored in memory. When we open a file, we load this file into memory, at least for now, and we create a window which is going to be this what we see in the terminal window. This is our window, the representation of what we see. And one buffer can have several windows at the same time opened. And when we say UI.refresh, so does it mean that we want to refresh on the specific window or in another window? Yeah. And if yeah, it also makes sense that we would like to have separate instances of UI for Windows, because when we redraw one window, no, we still want to redraw all the other windows as well. We don't want to make multiple windows with different states in them. It is okay if we want to make one window like scrolling with like maybe at the very start, at the very beginning of the file, and another window at the very end of the file. But when we have them both opened at the very beginning of the file, we want to see the changes that we type in one window simultaneously in the other window. I think this is how it should work. At least this is how it works in this Cocoon editor and in Emacs editor, which I also use sometimes. So it makes sense so far, and it also makes sense to have a single UI instance that we are going to pass by pointer. But for now we will not care about it too much. Yes, and we will just say that we we'll just say that we have a single window. We will have a test. I believe that both windows work fine. I think these tests are important from the very beginning, so we don't mess up the architecture too much that it's going to be a huge refactoring. But we are nowhere near these dangerous waters. So enough talk. Let's do some coding. We want to create a an event dispatcher in it, and we want to pass it a UI and a buffer. Okay, now after we have created an event dispatcher, render. What does even refresh do? It's not really a thing we should do. We should also re-render everything here. Refresh just flushes everything we have written to the buffer, so it doesn't really make a lot of sense to expose it here. Yeah, we should probably call render instead. But at the same time, we don't want to call render on the UI, because UI doesn't know what to render. We want to call render on the window. This is interesting, because now our event dispatcher have to know which window it should render to. And at this point, it doesn't really need to know about UIs. This is interesting. Okay. What do we have in the window interface? We say it init and we say it render, so it knows what to render. Yeah, I guess our buffers should know which windows they are displayed to. I had this idea before, but now it looks like yes, we need it. Okay, so let's say that Windows, and we will allow a maximum of 32 windows. Now we can't do it const, but I like the idea that we will have 32 constant read-only windows. You can't do anything with them. Okay, we don't really have. Oh, we will do like 32 window pointers. Yeah, this is what we are going to do. And even maybe we will do it. We will use some structure for the windows, like same array list, because we want to dynamically add and remove from it. But we also want to have a hard limit. Is there some hard limit? What's unmanaged? This array list retains ownership of underlying memory. Deprecated. Okay, maybe that's array list aligned, and here at the bottom, yeah, unmanaged. An array list, but the allocator is passed as a parameter to the relevant functions rather than stored in the struct itself. The same allocator must be used throughout the entire lifetime of the array list unmanaged. Okay, so it means that it doesn't store an allocator, and we have to pass it every time we do some actions with it. Okay, maybe we can have a window, a stack of windows maybe. Does it have a stack? Atomic stack. It has some stack with, as I understand. Oh, okay, I like that. We don't use our atomic functions and locks to do things if we are not multi-threaded. Yeah, maybe we can use this stack. Many read, many write, and non-allocating thread safe. Use a spin lock to protect push and pop. When building in single-threaded mode, this is a simple linked list. A linked list. Is there a linked list? Yes, there is. Single linked list. But we don't want a linked list. When building, we want a stack like an array. Okay, let's quickly build our array stack. Or we will just a slice. We will have to have a slice of window. I want to have a slice of pointers to windows, but I want to have like an upper limit of how many windows we can have at a time. And I think we will have to implement it. Yeah, maybe it can be pretty easy. Const our stack. I like this reference to communism. So we have some content. We will have to write an init function which is going to parameterize the length of a stack. We will have to write a function that is going to parameterize the type we're going to store. I don't want to do it right now, honestly. Okay, maybe we can just make it like this and assume that we will only use the first element and just add to do. Make it usable. For now, we just use a single element. Yeah, I like this solution. We can be pretty content with current implementation if we ever use just a single element. Okay, so now we need to tweak this a little bit. When we do init, we return self, and we want the buffer to have a pointer to our returned value. But at the same time, when we return from here, we cannot make this value a pointer because currently it is allocated on the stack. And we don't want to make pointers to things allocated right here on the stack, because after this function goes away, our stack pointer will be invalid. So I'm actually not sure how to do it. Maybe it requires an allocator to allocate this window thing, and only after that we are allowed to initialize it. Okay, maybe we can do a little hack, and for now just keep a pointer to the stack, but we will know that we have it somewhere. Fix me. We want to how do I say it? To not keep window on the stack. Yep. And we say buffer.windows.0 is a pointer to this window we have just created. And now, yeah, we want it to have just a single element for now. We say here that we don't want to refresh, we want buffer, windows, our window, and we want it to render. Okay, so this looks like what we want in the end. UI, render. Yes, so I think all the backbone structure is done. Let's call it here. Event dispatcher, dispatch, dispatch, and it wants a key and event, and we say insert character, which is equals to a key with value of 0. Okay, so let's see if it's going to run. Expected type buffer found UI 217. Okay, we no longer need a UI, fair enough. 149. Missing field Windows. Oh, right, that is correct. When initializing a buffer, we could also initialize a first window, but I think it is not our general pattern, so we can skip it. And 75 init dispatch, we don't have UI anymore. And buffer, we also accept a pointer to the buffer. Yep. 228. No member named insert character instruct event. Oh, I see. Because of we have such a complex structure, constructing events is not as simple. We will need an event, which is a value, which is an event value, and which is insert character is this key here. Okay, let's repeat this structure, which we just saw. Let's make it like so. 1, 2, 3, 4. And we want this whole thing to be a value. Okay, it doesn't allow me to do what I want. Please? No. How about this is going to compile even. Ignored, yeah, try. Expected type error found 84. Self buffer append. So it does return an error. Self buffer append, self content append. Let's go to array list. Fn append. Yes, it can fail. Maybe we don't expose the exact type. Yeah. We don't expose the possible error that can be from that. Self add one, and add one can fail. Ensure total capacity, and there should be an error somewhere. Error union, please, somewhere. So it says not a member of a destination error set. Yeah, we have it in buffer, so we probably should just add it somewhere here. Error, UI error, no, this is wrong. Buffer error. Okay, we have some more error problems. Expected type error, found error. Not a member of destination error set. Okay. And window error as well, I guess. Window.error. Does the window have an error? Yes, it does. Okay. Okay. Moment of truth. F. I don't see F. F. A. S. Okay, something is different. So we don't get pushed down the line. Okay, let's do one thing. Let's make it pretty. Let's put /r here first. And one more time. F G H J K L M N O P Q R. Okay, Control C still does things. Let's now remove all this printing. F Q S D. Okay, let's now try to check whether we actually add something to the buffer, or this line here just does nothing for us. We should inspect our buffer, and I think we can just inspect the length of our buffer. Let's output the length of our buffer. So we have buffer dot content dot items dot len, like so. Buffer len. Let's see if it changes. Yes, it does change. So we get I see. Because we add to the very end, and here we just show the first 41 lines, we don't get to see what's inserted, appended at the very end. So let's maybe insert it somewhere in the middle, maybe in the very beginning. Yeah. Maybe not at the very beginning, because we still don't show this first line. If we scroll down, it's invisible. Yeah, it's minor inconvenience. Maybe insert it at the maybe 20th position. Okay, I think we can do that. Pub fn insert 2. And let's see how this does it have an insert. Insert item at index n to make room. This operation is ON. Yes, it makes sense that it is ON, because we have to move all the memory one step forward. And an item T. Mem copy backwards. This is interesting. I will look at it maybe now. Copy all of source into depth at position 0. Okay. Okay, it looks kind of funny, because it has a very long name but very simple implementation. I expected something bigger, but okay. Insert, and maybe we shouldn't write insert, maybe the same interface as for the array list. Size, so n is for usize, we want to say index, and item, character. Our item is a character. Void try self content insert index character. And now, instead of appending it to the very end, we will insert it to the position 20. Okay. F A S T. Okay, maybe position 50. F. Oh, do you see it? Yes, I see it. Let's make it position 100 and let's make it bigger. Okay, position 100 maybe too much, maybe too little. So we need a fourth line. Okay, let's not make it too big. Okay, maybe like so, because it wraps around the lines. Yes, yes. And let's write hello. Oh. Hello world. So it is backwards, so we should write hello world backwards. Let's put some spaces and write hello world backwards. World. Okay, it's hard, but I can manage it, I believe. World space and hello should be easier. Hello. Ah, we managed it. All right. We have our hello world by appending inserting in the array of our code editor, and in some sense we can already edit our code. It is a functional program at last. Okay. Let's say that we did some progress. We can finally insert some lines. Yeah, we can insert characters in our content. Okay. So this looks very nice. I like what we have right now. So I think at this point we can end our little series. We have created our special way of handling user input. I guess it is nothing too special, but at least we didn't just copy it from somewhere, but did it ourselves. And we also made our event dispatcher aware of the buffer, and we said that here we will do it through the buffer that we insert a value, and we do it through the window that we render a value. I think in the future we will either have a special entity that will know about the buffer, and it will know about the windows in the buffer, and it will accept commands like insert or other commands. So just a general entity that knows about commands. So this one, dispatch, it knows about events. It is one level, like events, like notifier, yeah, like notification that something has happened. And maybe we will have another entity that will actually perform commands. Since we are going to have a client-server architecture, this entity can be different for server and for client, because all these entities, they don't really care where they live. I mean, it makes sense that window or maybe buffer, they live on the server, because it should just connect to several clients. Yeah, we are going to have some code splitting pretty soon, I think. Okay, so I think this is a nice series. I liked the progress we've made. We have been able to insert a character which is not too big, but at the same time it is fascinating. I like what we have. So see you in the next series. I hope we will also use, we'll do something interesting again. And I hope you're doing well. So have a great day, evening, or morning. Bye.